Hi guys, today topic we are going to see flow measurement. Under flow measurement we are going to see about orifice meter. What is flow measurement? Why we have to go flow measurement? If you want to measure a flow rate of liquid and gas, it is very much essential to maintain in the quality of industrial process. Because in most of the industries are consisting of control loops to control the flow rate of incoming liquids or gas to achieve a particular control in Pakka manner. And the flow rate may be like volumetric or mass flow rate, and the medium could be gas or liquid, and the measurement could be intrusive or non-intrusive. And the flow meter, industrial flow meters are commonly under these categories. The first one is about obstruction, otherwise known as differential pressure or variable area. Then inferential, that is nothing but turbine type. Then third one is about electromagnetic. Then positive displacement. Fluid dynamic is otherwise known as vortex setting. Then anemometer, ultrasonic, and mass flow meter. So in Speak, you all know Speak, which was situated in Tuticorin. In Speak, most of the the areas, they have kept mass flow meter, that is nothing but Coriolis, and moreover they are having magnetic meter. These are the meter they are using, and moreover they are using orifice meter, and the orifice meter which comes under the category of obstruction type. So how they are grouping these types of flow meter? Obstruction or head type flow meter, differential pressure type, and variable area type. What does it mean, obstruction or head type? So when you comes for this obstruction or head type flow meter, the types are differential pressure and variable area. Differential pressure, which is nothing but orifice meter, venturi meter, pitot tube. Then variable area, which is nothing but rotameter. In all the cases, the obstruction is created in the flow passage. So where the pressure drop across the obstruction is related with a flow rate. So all the measurements are indirect measurement. Why? Because we are just going to calculate the pressure in terms of flow rate. So we are going to calculate only the pressure difference. That is the reason these flow meters are called indirect measurement. So what are the basic principle? Generally, when you are talking on this flow, the flow can be two types. One is viscous and the another one is called turbulent. So how it does differ, viscous and turbulent? Viscous and turbulent, they are varying in the concept of Reynolds number. So when the flow is viscous or turbulent, if the Reynolds number which is greater than 2000, then the flow is turbulent. But in most of the cases, we are having the flow is turbulent flow. So that is the reason they are pointing out all the industrial, whatever the flow meters we are using, the flow is turbulent flow only. And here we have considered the fluid flow through a closed channel of variable cross section. So in this diagram, you can just have a look on it, and just giving two channel, that is channel 1 and channel 2. And the passage, this is nothing but the flow of liquid. In each channel, we have kept P1, V1, Z1. P, which is pressure, and V is nothing but the velocity. Then Z is datum. So likewise, we are just considering the how the Bernoulli's theorem works for this particular thing. So here the flow is flow through a varying cross section. And here one more thing is, we are concentrating on the fluid flowing is incompressible. So how they are calculating the fluid flow rate in an incompressible fluid? So in channel 1 and channel 2, they are varying cross section, and here we are considering two cross section of channel 1 and 2. And for section 1, the corresponding values are P1, V1, A1, Z1. And for section 2, it is P2, V2, A2 and Z2. And here it is in fluid flowing is incompressible. So from Bernoulli's equation, it is nothing but P1 by gamma plus V1 square by 2G plus Z1, which is equal to P2 by gamma plus V2 squared by 2G plus Z2. And gamma, which is nothing but a specific weight of liquid. So according to Bernoulli's equation, we are having the expression P1 by gamma plus V1 square by 2G plus Z1, which is equal to P2 by gamma plus V2 square by 2G plus Z2. If Z1 is equal to Z2, then your equation is become P1 by gamma plus V1 squared by 2G, which is equal to P2 by gamma plus V2 squared by 2G. If the fluid is incompressible, so there is an equation V1A1, which is nothing but V2A2. So when you are substituting this V1 and V2A2, you will have the expression V1, which is nothing but after this expression, you will get a value of V1, that is nothing but V2A2 divided by A1. And here this A2 and A1, they are the cross-sectional area. And A1, which is nothing but the cross-sectional area of the fluid pipe. And A2, which is nothing but the cross-sectional area of the orifice plate, if you are concentrating on orifice flow meter. And when you are concentrating on this expression, I am just getting the value of V1. So if I am going to substitute this V1 value, I can able to get the given expression in terms of area. Before getting into that, I am just going to substitute it. This P1V plus V1 squared by 2G is equal to P2 by gamma plus V2 squared by 2G. After simplification, I will have V1 square by 2G minus V2 squared by 2G, which is equal to P2 by gamma plus P1 by gamma. So from this expression, I can able to find out V2 squared minus V1 square. So once you are having this V2 squared is, if you are taking out, you will have 1 minus A2 squared by A1 squared, which is equal to 2G by gamma of P1 minus P2. So this is what your pressure difference from 2 points. So out of this expression, I can able to get the volumetric flow rate, that is my velocity, that is V, which is nothing but 1 divided by root of 1 minus A2 squared by A1 square after substituting the value of A1 V1 equal to A2 V2, root of 2G by gamma of P1 minus P2. So here A is an area. So I am just going to express the given expression in terms of diameter. So beta, I am just going to assume D2 by D1. So what will have A2, which is nothing but beta square. So now the equation is going to become V2, which is equal to 1 by root of 1 minus beta power 4 into root of 2G by gamma of P1 minus P2, where V2, which is nothing but the volumetric flow rate through the channel. This is what we are going to calculate it. So your flow rate, it is related to the pressure difference. So using this pressure difference, we are just going to calculate the flow rate of a particular pipe. This is how they are calculating. And one more expression, that is nothing but Q, that is discharge coefficient, which is nothing but V2A2, which is equal to A2 divided by root of 1 minus beta squared into root of 2G by gamma of P1 minus P2. So from the above expression, we can infer that if there is an obstruction in the flow path that causes the variation of cross-sectional area inside the closed flow channel. And moreover, this expression is only valid for incompressible fluid, that is liquid, and the relationship between volumetric flow rate and the pressure difference is non-linear. So how to become the particular equation into linear? Then we have to get into signal conditioning circuit. Using this signal conditioning circuit, we can make the given expression into a linear one. So for that we are using square rooting circuit. So the next one we are going to see about the orifice meter, how it is going to work. So before getting into orifice meter, just I would like to show a small demo on the orifice meter. How? Yes. Can I able to see the orifice meter now, right? So this is for the measurement of differential pressure flow measuring meter. For this orifice meter, you can able to visualize it. That is nothing but your orifice meter, which consists of two tubes. The tubes are nothing but your YouTube manometer, which is connected the center place of the pipe, and those two tubes were connected to the differential pressure transmitter they used to call DPT. So inside this DPT there is a pressure sensor called diaphragm or bellows, and these two tubes are connected with an orifice plate, and the orifice plate which is kept inside the flanges, and this is the flow path. So in the flow path, if you are open, if the flanges are open, then we can able to see inside there will be one circle with an hole. That is what call it as an orifice plate. So when you are looking at here, this is the flow path. In the flow path you have a circle. This is what your orifice plate we can call. This is the hole and the circle. These orifice plate you are having two tubes, and those two tubes are connected via your diaphragm. So if the are bellows, and here it is bellows, and because of the vibration of the bellows, automatically here you can able to look at two tubes are there. So if according to the flow, this is called convergence, this is divergence. So you can able to see in the convergence and the divergence how the velocity and how the pressure. So based on that, your pressure difference can able to measure using this YouTube manometer. The difference can be changed according to the pressure sensor which is connected in the downwards. So this come your flow path. So this is how your orifice meter is working in the industrial point of view. You can able to see here, if the convergence, if the velocity is more, your pressure will be high. If here, what will happen in the divergence part, automatically the velocity depends on the pressure. So in the downstream, if the fluid comes out of the orifice, your pressure is going to become minimum. At the upstream, the convergence of fluid, so your pressure will be maximum. So automatically we will get a pressure difference P1 and P2. So we can able to measure the pressure difference using your YouTube manometer, which is connected on those 2 points, that is nothing but your P1 and the P2 points. This is how the pressure difference is measured via this orifice meter. So this minimum cross-sectional area of the fluid obtained at the downstream from the orifice edge, which is called vena contracta. So this is how the construction of the orifice flow meter which looks. So in the panel, we can able to identify the manufacturer value and the readings, and these are all the adjustments they have made. So I think you will understand